Hello friends, in the previous lecture we have seen that what is meant by conjunction of a proposition, disjunction of a proposition. Also we have studied what is meant by conditional statement and biconditional statement. Today we have to discuss about the examples on that four types of statement, like conjunction, disjunction, conditional and biconditional statement. So let us take first example. So your first question, by using truth table, prove that P implies Q is a logical equivalent with negation P or Q. Okay, what is your question? By using truth table, we have to prove that P implies Q is a logical equivalent with negation P or Q. Okay, so how many statements or how many propositions we have given? So we have given two propositions. So in that truth table, how many rows? So that is 2 raised to 2, because we have given two propositions. So we have to take 2 raised to 2, that is 4 rows. Okay, so let us start the solution. So for the truth table, so you have first column for P, okay, second column for Q, next we have to also make column for negation P, right? Next column for negation P, right? Next column for P implies Q, right? Last column for negation P or Q, right? This is your 5 columns. And we have to make the 4 rows. So there are 5 columns and 4 rows. Why these 4 rows? Because there are 2 propositions. Suppose there are 3 propositions. Then how many rows? This is 2 raised to 3, that is 8 rows. Okay, so this is your table. So in that your first column for proposition P, we have to take the first 2 values. First 2 value is P, and remaining last 2 value become F for proposition P. Okay, similarly for your proposition Q, we have to take the value alternate, that is P F again P F. Okay. So next third column becomes negation of P. So negation of T become F. Right? So we know that negation of T is F. Again negation of T is F. Again negation of F is again T. Again negation of F is again T. Okay? So next column is P implies Q. So we have to study the definition of, that is the conditional statement. In that conditional statement, P implies Q means value of TF is F. So we have to check that only TF where? TF is only in the second row, so value of TF is F. In all other cases, value becomes T, right? So your last column becomes negation P or Q. This is your negation P, we have to take negation P or with Q. Okay? So in that, this is or, this means your disjunction table. So in that your disjunction table, we have to check that where is both F. Okay. So in that your disjunction table, where is both F? Here is F, here is F. If both F, then its value becomes F. Right. So your disjunction table, you have said that if both value F, then its value becomes F. So there is no condition, other condition. There is no where both F. So if both F, then its value is F. And in all remaining cases, it will become T, right? So from column 4th and column 5th, it says that both values are here T, both value F, again both value is T, both value T. So this column 4th and 5th says that, therefore, from 4th and 5th column, we get, that is your P implies Q is logically equivalent with negation P or Q. Okay, hence proof. Okay, this is so easy example. So let us take the second example. We have to discuss the three definitions. What do you mean by tautology, what do you mean by contradiction, and what do you mean by contingency? If that three cases occur in your given statement, that is your compound statement, so we have to discuss one by one. So let us define your first definition. What do you mean by contradiction? Okay. So what is the contradiction? If a compound statement capital P, if compound statement capital P containing P1, P2 up to PR. This P1, P2 up to PR, all these are your R simple statement. So this compound statement P containing all R simple statement is said to be contradiction if that your capital P compound statement P has all its values become capital F. Okay, that means if in your last column of your truth table all values become your F, then this your compound statement is said to be contradiction. Okay. So let us discuss the second definition. What is meant by contingency? If a compound statement P containing your P1, P2 up to PR, all these are your R simple statement is said to be contingency. If the compound statement P has truth values T and F, if compound statement P has truth values T and F, that means in your truth table, your last column containing both values T and F, both values is appear. That is, your P is neither tautology and contradiction. This your statement is neither tautology and contradiction. Now, what do you mean by tautology? We have to discuss. So, what do you mean by tautology? If a compound statement P containing P1, P2 up to PR, these are your R simple statement. If compound statement P contains your R simple statement is said to be tautology if P has all truth values capital T. That means if your truth table containing your last column, that is all values become T, then this your statement is said to be tautology. If a statement is neither tautology nor contradiction, that means in your truth table containing all values become TF, both values are accurate, then that your statement is said to be contingency. Okay. So let us take the example. Construct a truth table for Q implies negation P. Construct a truth table for Q implies negation P or negation P implies negation Q. Okay. You have to make the truth table for Q implies negation P or means disjunction. Negation P implies negation Q. That implies is conditional statement. Okay. So in that your statement, how many propositions? So there are only two propositions containing P and Q. So there are two propositions. That means in your truth table, how many rows? That is 2 raised to 2. That is 4 rows. Okay. So write down solution. So your first column containing proposition P, your second column containing your proposition Q, your third column containing proposition negation P. Okay. So column number 4 for negation Q. Right. Next column number 5 for Q implies negation P, right? Next, 6 number column for negation P implies negation Q. Your last column for Q implies negation P or negation P implies negation Q. This is your 7th column. Okay. So you have to make the table for that 7th column, and in that table there are 7 columns and 4 rows, right? Because there are 2 propositions. Okay. So we have to draw these 4 rows. Okay, so this is your truth table for before obtain table. You want to make the table containing the 4 rows and 7 columns. So in that your first proposition for P, in that your first column containing first 2 values T and then remaining 2 values F for proposition P. Same for proposition Q, we have to get alternate values TF. Okay. Next, for we have to find negation of P. Negation of P means we have to get negation of T. Negation of T is F. Again, negation of T is F. Negation of F is T. Negation of F is T. This is column 3rd. So your column number 4 contains negation Q. Okay. So negation of Q. Negation of T is F. Negation of F is T. Negation of T is F. Negation of F is T. Next column, we have to prepare the Q implies negation P. This is your column number 5th. This is your Q, this is your negation P. Q implies P. So in that your condition statement, if value first column value is P, second column value is F, that is TF is F, right? TF is F. Check other, where is TF? No TF. If TF is F, and in remaining cases value become T for your conditional statement. Same for this is your negation P implies negation Q, that is 3 implies 4. Column 3 implies column 4. We have to check that only where is TF. So in the 3rd row there is TF, that means its value is F. What is my implication case? If value first and second is TF, then its value become F. In the remaining cases, its value become T. Right? What is your last column? Last column for Q implies negation P or negation P implies negation Q. That means we have to get disjunction of column number 3 and column number 6. Okay. In that disjunction, we have to check that if both value is F, check where is both value is F. So no where is both F. If both value is F, then its answer is F. That means its truth value is F. So there is no if both F, so that means its value is T. Okay. So from your last column, so all values are your T. So you have to earlier discuss about what is meant by tautology. So your given statement is tautology, right? Because all value containing all truth value is T. So your given composition statement is tautology, right? So given proposition, given proposition is tautology, right? So your given proposition is tautology. Why is tautology? Because all truth values in your last column becoming T. Therefore, your given statement is tautology. So let us take the second example. Let us take the second example. Construct a truth table for negation P, even only negation Q. Construct a truth table for negation P, even only negation Q. Even only Q, even only R. What is your second example? So your second question is construct a truth table for negation P, even only negation Q, even only Q implies Q, even only R. Okay. So in that your statement, how many propositions? So there is P, there is Q and R. So there are 3 propositions. That means in that your truth table. So how many rows? That is 2 raised to 3 rows. That is your 8 rows. Okay. So write down solution. So this is your first column. So this is your second column for proposition Q, right? Again third column for your proposition R. Okay. Next, we have to make the negation P column also. Next column for your negation Q also, right? Next column for negation P, even only negation Q, right? Next column for Q, even only R, and your last column for we have to take even only of that 2 statements. That is column number that 2, 3, 4, 5, 6 and 7. We have to take the last column for column 5 and 6 is biconditional. That is your negation P, even only negation Q, again even only Q, even only R. This is your last column. Okay. So there are 8 rows, right? And 1, 2, 3, 4, 5, 6, 7, 8. This is your last one. Okay. This is your truth table for given statement. So in that your truth table, there are 3 propositions. That means there are 2 raised to 3. That is 8 rows. Okay. So for that your first proposition P. So we have to take first 4 value, that is half of 8 is 4. So we have to take first 4 value is T and last 4 value is F. Okay. This is 4F value, this is your 4T value. Next, for your second proposition, we have to take 4 of half. 4 of half is 2. So we have to take again 2T values, again 2F values, that is alternate. Again 2T value, again 2F values. Okay. And for your last 2 propositions, we have to take all these are your alternate value 1 by 1 by 1. That is your TF, again TF, again TF, again last is TF. Okay. So your next column is negation of T. That is your negation of that first column. So negation of T is F. So there is 4 first F value, right? Then 4 T value, right? T means true, F means false. So next column is negation of Q. That means we take negation of second proposition. That is second column. So negation of T is F, negation of T is F, negation of F is T, negation of T is F, negation of T is F, negation of F is T, right? So your next column is negation P if and only if negation Q. That means you have to take of that both column of if and only if. So in that your if and only if, that is in your biconditional statement. Biconditional statement says that if both values are identical, that is both values are same. So you have to only check that both values are same. If both values are TT and both values are FF, then it's your result value of, that is your truth value become your T. So both values are same, then its answer become T. You have to only check that both values are same. Here is no same. If both values are not identical, that is not same, then its value become F. Same. Here is not same, then its value is F. Here is not value same, then its value is F. If both values not same, then its value is F. Both values are same, then its value is T. Both values are same, then its value is T. Okay. Same for Q if only R. So you have to make this Q and R. Same question. If both values are same, then both truth values are identical, that is TT or FF, then its value is T. So both T, then what's your value is T. Both are different. So then its value is F. Again this is different, then its value is F. Again this one are same, so its value is again T. Again both values are same, then its value become T. Here is value are different, then its value is F. Again value this one is different, then its value is F. So last row both values are same, that means its value become T. So your last column is going to take that your column number 6 and 7, that of its double implication, that is your biconditional. So in that your biconditional, that is in your equivalent case, if both values are same, then its value become T. So these both values are same, its value become different, then its value is F. Again both values same, its value is T. Different value, then truth value is F. Different value, truth value is F. Same value, truth value is T. This is your again different value, then its value is F. Again last value is same, then this is your truth value is T. So in your last column, we observe that truth value become alternate, that's TF, 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 that's mixed values. Okay. In your last column, so we get both truth values T and F. So the given statement is your contingency, right? So from your last column, so given proposition. So given proposition is contingency. Given proposition is contingency. Why this contingency? Because your last column containing truth value is T and F, that is both truth values. Okay. So I hope all parts you have to understood. So remaining part we have to study next lecture. Thank you.